Bismillahirrahmanirrahim. How are you, students? Today we will study unit number 18, lecture number 30, subject physics. Today we will do numerical problems. Now you can see the first numerical on the screen. It is the half-life of nitrogen is 7.3. So half-life is 7.3 second. A sample of this A sample of this nuclide of nitrogen is observed for 29.2 seconds. So this is the time for which observation is made. Calculate the fraction of the original radioactive isotope remaining after this time. So half-life is 7.3 seconds. This is half-life. This is the time for which we take observation. So after a time of half-life 7.3 seconds, 1 by 2 you will write the sample 1 by 2 amount of sample in not original. After second half-life 1 by 2 square n naught is equal to 1 by 4 n naught. Of the third 1 by 8 1 by 8 or 1 by 2 power 3 n naught is equal to 1 by 8 n naught. So 29.2 second contain number of half-life is 4. So you will calculate the amount of sample after 4 half-life. So you will do it. Half-life is 7.3 second. Time for which observation is made is 29.2 second. So number of half-life, you will divide t by t1 by 2. You will get 4. This term divided by this, you will make the calculation. Or I will write number of half-lives is equal to 29.2 divided by 7.3 is equal to 4 half-lives. The sample lifted amount of sample equal to 1 by 2. We want to calculate after 4 half-life, so we will write 4 into amount lifted. So 1 by 32, the amount lifted will be 132, sorry, it's 116 of original nuclide present. Now the next question, cobalt 60 is radioactive element and half-life is cobalt 60 is given with half-life this. What fraction of the original sample will be left after 26 years? So we have to calculate the sample lifted after so much time. So you will write number of half-lives is equal to 1 by 2. Number of half-lives is equal to time observation and half-life divided by half-life. So number of half-life, if we represent it by n, we will write 26 divided by 5.25. It's almost 5. Number of half-life is 5 in round figure. So the amount of sample will be lifted. We will do it amount of sample simple after first half life is 1 by 2 original nuclei. Amount of sample after second half life is equal to 1 by 2 square in naught. So amount of sample, amount lifted after fifth half life is in naught. So you will write the answer here. It's almost 132 that of original nuclei. Now the element is given, radioactive element is given, which have half-life of 36 minutes. If there is 200 milligram, the amount is given 200. So how many amount will be lifted after 6 half-life? So after first half-life, the amount will be reduced to half. After 36 minutes, reduced to 100, half. Within 30, reduced to 50. Next half-life. Within 24, reduced to this, and so on. I will do it on next page. We'll do it on blank page. The amount, make a table like this. Here write the amount, here time. Originally 200 is present. 80 after first half life it will reduce to 100. After second half life it reduced to 50. After third half life it reduced to 25. After fourth half life it reduced to 12.5. After fifth half life it reduced to 6.25. and after sixth half life it reduced to 3.12. So after sixth half life, this is the originally present. First half life reduced to half, and third half life half of 100, half of 50, half of 25, and so on. So make a table and do it with the help of table. Now 18.3, carbon 14 has a half-life of 5730 years. How long it will take for the quantity of carbon 14 in a sample to drop to 1/8 of the initial quantity? So first we will write the data. This is half-life of carbon. Time required for half-life for first half-life is 5730 years. Time required for second half-life is this one multiplied by 2. And time required for third half-life is multiplied by 3, 1.72 cross 10 raised to power 4 years. So it means that after third half-life 1/8 of the initial quantity is left, and 1.72 cross 10 raised to power 4 years time is required to decay. You can do it in another way also. Time per half-life is this one. Quantity is not given, so write the how long it will take for the quantity of the sample to be left 1/8. So n is equal to 1 divided by 2 power n in naught. This is the original and this is lived it after first half life or second half life or third half life. This is the generalized form of the equation. So 1 8 means n is equal to 1 divided by 2 power 3 n naught. 8 is 3 times of 2, so this figure represents 8. So compare these two equations. 1 by 2 power n naught is equal to 1 by 2 power 3 n naught. This is cancelled with this one. This is compared with this one. So 2 power n is equal to 2 power 3. So 2 is cancelled, n is equal to 3. Third half life. Now next question is half of a reduced element is 10 minutes. Half life is 10 minutes. It initially count rate is 368. Initial count rate. Three six eight. Find the count rate which counts rate reaches 23 counts per minute. So after 10 minutes, half life is 10. So after 10 minutes, count rate will be reduced to half, 184. After 20 minutes, it will be reduced to 92, and you will keep continue. So after 30 minutes, the count rate is reduced to 46, and after 40 minutes it is reduced to 23. So after 4 half-life it is reduces to 23. Now in an experiment measure the half-life of a reduced element, the following result can be obtained. So draw a graph for it. It is not in your syllabus. So if you want to plot a graph, you will take count rate along y-axis and the time along this axis, count rate along this axis. You will get a graph like this, but it is not in your syllabus. 8.7 is also not in your syllabus. A sample of certain radioactive element has a half-life of 1500 years. Half-life is what? 1500 years. Rate of activity is 32,000 counts per hour. Plot a graph of the activity of this sample over the period in which it will reduce to 1/16th of its present value. 1/16 is equal to 1 divided by 2 power 4. So after 4 half-life you have to calculate the graph, and the graph will be a curve. The graph will be like this. Now half-life of a radioactive element has found to be 4000 years. The count rate is per minute per 8 successive hours are this. So what does this variation count rate show? And we have to plot the graph also. So first you will take count rate along y-axis and time along x-axis. Take count rate along y-axis and time along x-axis. So when you take count rate along y-axis and time along x-axis, you will draw a graph and it will be a horizontal straight line. So it's a graph, you will do it by yourself. Ashes from a campfire deep in a cave show carbon-14 activity of only 1/8 the activity of fresh wood. How long ago does the campfire made? This is activity, and this is the half-life of carbon. You should memorize this one. And we have to calculate the you will write the formula. N is equal to 1 divided by 2 power n not original atom. So campfire carbon 14 half-life, we know it, 5730. This is carbon 14 half-life. So we have to calculate the amount 1/8 activity of only 1/8. So 1 divided by 8 n naught. So n is equal to 1 divided by 2 power 3 n naught. This is the equation we written from this. 1/8 they have considered of original nuclei. So compare this equation with this one. Compare these two equations. n is equal to 1 by 2 power n naught, and the second equation that we write according to a condition of the question is 2 power 3 n naught. Compare these two. 1 divided by 2 power n naught is equal to 1 divided by 2 power 3 n naught. Cancel. 2 is cancelled with 2. N is equal to 3. You should calculate the amount left after third half-life. So 1/8 amount will be left after 3 half-life. So 5730 multiplied by 3, you will get the answer. The amount left, 1/8 of amount will be left after third half-life. Thank you, students. Allah Hafiz.